All right, everybody, welcome to lecture 5. Now, this has a little bit to do with what we talked about in the last lecture, which was basic nutrition. We ended the lecture, or part of the lecture was about weight distribution. I talked a lot about that. How not, and I said not to worry necessarily about your weight all the time, but we want to worry about like that, what our actual makeup is, our composition, and that's what we're talking about in this lecture. How to measure it, different classification for it, what's good, what's not good, what you should use as measurements to make sure that you're actually progressing. So body composition really is just the distribution of fat, muscle, water, and bone. Okay, bone usually is what it is, but what we're mostly concerned about is our muscle, fat, and water. Things that we can manipulate day to day or hour to hour, whatever, is water. We can't really change our bone, fat, and muscle that quickly, but things we are trying to influence over time is muscle and fat. Usually we're trying to lower fat, increase muscle. Okay. The big thing is how do we measure that, right? So if we're measuring weight, you step on a scale. Right? If we want to measure our composition, what like our makeup is, there's different ways you can do that. There's some that are good, there are some that are not good. Okay, so the different ones are BMI, skin folds, it's called bioelectrical impedance. You can just write BIA, and then hydrostatic weighing. Okay, so basically, the different methods are good for different things. The one that sucks, honestly, is BMI, and I'm sure all of you have kind of had your BMI told you before, and basically the problem with BMI is that it's really just saying how much like space you take up and then comparing it to a standard of what you should be within that space, but it doesn't actually break down for you like what makes up that space, okay? So I want you to skip down to the BMI equation, right? And I'm going to go through like the example. I just did it for myself so that we can see what happens as we calculate my BMI. There's a couple equations that you need to know in this, or conversions. Sorry, there's a couple conversions you need to know, and I'm going to tell you them to you right now. I'm going to walk you through how you would figure this out because in the U.S., we don't measure weight in kilograms, we measure in pounds, and we don't measure height in meters, we measure in inches. Right, so in order to do that equation correctly, you have to make sure you convert your numbers over from pounds to kilograms, and then from inches all the way to meters, to make sure that you're actually using the right numbers for the equation, so that it fits within that classification chart, which is right below if you see with all the different colors. Okay, so conversions, number one, and these are ones that you need to know for the rest of the time that you're going to be involved with exercise science. Okay, so the first one, pounds to kilograms. Okay. If you want to go from pounds to kilograms, you need to divide the number by 2.2. Okay, so for example, I weigh 222 pounds today. If I divide that by 2.2, then I yield 100. It's 100.9 something, so I yield 101 kilograms. Right? That's conversion number one. It's either you divide, so from pounds to kilograms, you divide by 2.2. If you want to go from kilograms to pounds, you multiply by 2.2. Okay. Second, inches to centimeters. If you want to go from inches to centimeters, you multiply the number by 2.54. Okay, so it would be the other way if you're going from centimeters to inches. Okay, so for example, I'm about 5'9", which means I'm 69 inches tall. If I multiply 69 times 2.54, then I get 1.7, or sorry, I get 175.3 centimeters, right? I get 175.3 centimeters, okay? Now, if you notice, it's not centimeters in the equation, it's meters, right? So, and this is where the 175 came from, right? So if you want to go from centimeters to meters, you need to multiply by 100, okay? If I wanted to go from meters to centimeters, I would divide by 100, right? So the conversions are there for you to make sure that you're able to do this equation, and also just to be in a game for the rest of the time you take class here, because these are gonna come back 100%. Okay, you could probably go look up a conversion for inches to meters. I'm sure there's one out there, but the two-step way is to do it like this. Okay, so the first thing you should do when you're calculating the BMI is get those numbers first and then plug them into the equation, right? So we know for me that I'm 175.3 centimeters tall. You multiply that by 100. I'm 1.753 meters tall. Okay, so when we look at that equation, 1.753 goes into the meters. We know that I'm 101 kilograms, so that goes in there, right? Now, I'm telling you, this is it's an important step, and it's like mostly missed when you're going through the conversions. Do not forget to square the meters. Okay, so I have a 1.753. I need to square that before I actually put it in the equation. A lot of people make the mistake of not doing that, and then you get a weird number because you didn't do that, right? So we plug in 1.753 squared, which is 3.06. That's the number that goes in height. On top, I got kilograms. That's 101 kilograms. So I divide 101 by 3.06. I yield a number, a BMI of 33.0. Okay. So now I want you to go down and look at what a 33 BMI yields on lecture 5. Okay. And if you look, I am class 1 obese. Now, I am not class 1 obese, right? I just am a bigger person in a smaller space. So the problem with this is that it's only taking in account how much space I take up or how much mass I have within a certain amount of space, right? So if I was taller, then I would not be classified as obese, right? But I still probably would be pre-obese or overweight, right? The problem is that you're not breaking down what I actually am according to muscle, fat, bone, and water. So that is where BMI really loses a lot of people and it loses a lot of credibility, just because like I could be or somebody could be gaining weight but gaining lean muscle mass, and they could actually on this chart be getting worse, which isn't really something that's going to help as a good measurement. Okay, so that's really the big problem there, is that this isn't representative of, like, this is not a representative number of what we're actually trying to accomplish. So that's why we tend to stay away from BMI. We want something that's going to give us more information, and that's about the actual distribution of what we're talking about. So the next one after BMI is a skin fold, okay? A skin fold is really just going to tell you only your fat. It's only going to tell you how much fat percentage you have, because what you're going to do, and I'll get to the problem for a sec. I'll get to the problems with this in a second. But with skin folds, there's very specific spots that you're literally going to have pinchers, and you're going to pinch your skin and pull on it, and then you measure the millimeters or the distances of how big it is. You plug that all into this big equation after you take account into all the different spots on the body. And when you take all that into account, it gives you a fat percentage. So when it's done right, very, very accurate for body fat. It is hard to do right, though. So you have a better chance of messing it up, honestly. And even with the equation, too, unless you have it already plugged into something, if you're if you're doing it by hand, like, there's a really strong chance you're going to mess it up, right? And that's just because it's a very complicated equation. I forget what exact class that you do those in, but you will have an opportunity to do a skin fold at some point, and you'll see like that it's pretty difficult to actually get it correct. But if you do, it's really good. Problem with that, it takes forever to do it, right? Unless you're really good at it, right? It takes a while to do that. So unless you're working with somebody one-on-one, if you were trying to get a bunch of measurements on 10 people, like for you to go through 10 skin folds is going to waste a ton of time. So honestly, the most practical, the most practical one is bioelectrical impedance, BIA. Okay, so BIA is really like the one that if you're in a big setting or a practical setting, or you're just trying to get like a quick number, that's the one to go to. So all it is, it's a little like handheld machine, and even like scales have this on there too, and that's the one where it can tell you your body fat, but it's using BIA through your feet to figure out how much fat percentage you have. So all it does is it sends an electrical signal through your body, and it's measuring the speed at which it goes through. So muscle and water are very good conductors of electricity. Fat is not. So when you hold the thing and then it sends this signal all through around your body, if you have a higher fat percentage, the signal will be sent through slower. So if it's a slower signal, then you're going to get a higher number. If you have less fat and you have a little bit more muscle or more water in your body, that speed of the signal is going to go around crazy fast and you're going to have a lower number. Now, if you notice, I emphasized the water part, right? So hydration status is going to have a huge effect on that number, right? And this is where the error comes in with this one. So even though you have a nice, really easy way to do it, you have to make sure that you're hydrated the same way for each test. Otherwise, it's going to be different because water and the influence of water will influence the speed of the signal, right? So if you're super hydrated and you like overly hydrate, we're going to have more water content, which would make the signal go faster, and now your fat percentage looks lower. So if someone happened to drink a gallon of water the night before you test them, they get a really low number, and they're like, yeah, I improved. Great, this is awesome. And then a couple weeks later, for some reason they didn't hydrate at all, and maybe they drank or something the night before, and then they come in, and now they're actually got worse, right? Their number's higher because they're not hydrated as well, so that signal's going slower. Now your client is in a spot where they're thinking, oh man, I'm getting worse. What am I doing? I need to change something that I'm doing, yada, yada, yada. So if you don't have that information in mind, you don't know that could influence it, that could cause some problems for your client, especially when we're trying to progress on things, okay? So that's a really important one for you to make sure that you understand how the BIA works and then what the big problem with it is as far as hydration. You can combat that just by making sure the person's hydrated the same. Okay, and again, practically, that's probably your best bet if you're in a bigger situation or you need something quick. Okay, gold standards. So this lecture is a little bit old. So hydrostatic weighing works basically by like you sit in this like seat and you're going to this giant like hot tub looking thing, and then you have to like immerse yourself fully in the water. You completely let out all of your air so your air isn't lifting you up in the water. And then basically it's like measuring the displacement of water. So if you look below, muscle and bone weigh more than fat because they're more dense. So you'll displace less amount of water per given body weight if you have more muscle and bone. So what they're going to do is look at the displacement of the water. You throw it into this big calculation. And that's really the gold standard, or was the gold standard at the time, to get the most accurate measurement possible. When we look at practicality, that is a huge setup to have, right? It's like this giant hot tub looking machine. You got to get somebody in there. They got to go down, let out all of their air underwater and hold it there for a second and then come back up, right? So practicality, you're not getting a lot of people through that process quickly. Two, if someone's like not really comfortable letting out all of their air underwater and holding it and they mess it up, well, then you got to do it again. You could kind of mess with the person. So there's a lot of problems with that one. But again, it's like the skin fold thing. Like if it's done well, it's really, really accurate. Now there's a thing called DEXA scans. It's literally like an X-ray scan that like gives you the exact percentage distributions of not only fat and muscle, but it also gives you like your specific fat percentage, muscle, bone, like, and a ton of other things too. I've personally never used it. I've only heard of it. I think there's one at the Lehigh Valley Pocono now, so maybe at some point, depending on the route you take with ESU, you might get to go use that, which would be pretty cool. But that is now really the gold standard because it's something that's going to be extremely accurate, like on all levels. So it's like instead of you just knowing your fat percentage, you're going to know everything. Big problem with that one, lots of money for that, right? So at the end of the day, practically speaking, you're going to be better off just hitting a BIA and kind of calling it a day as far as from a practical real world setting, right? Like if you're, I train athletes and people personally, like I'm not going to go try to sign them up to get a DEXA scan for no reason. Like it's going to cost them money. It's going to waste a session. It's going to look, I'm cool with a measurement as long as it's consistent, right? So if it's a consistent measurement, then whatever's happening with that measurement, if it's going down, we're doing something positive, right? So that's really where you want to understand how to measuring and what's important with measurements and whatnot. So if you scroll down a little bit in the lecture, I went over the BIA thing. You got to just be careful with the hydration part of things. At some point, you'll get to use those too, so don't worry about like actually seeing what it is or using it. Just understand it. It's a handheld device, and that's how it pushes the signal through your body. It's like this little handheld device. You put in all your heights and your weights, your gender, and it like takes all that into account when it's calculating the equation. And then note hydration status like greatly affects it. It's a really big deal. Okay. Lastly, these things here called somotypes. It's important for you to know this just from a terminology standpoint, as far as like helping people understand like kind of like what body type they are, and different body types have more similar characteristics to each other. So really, I look at these as a way to kind of program someone baseline. Like, if you know somebody, and this is stuff right? It's like if you look at it like you got somebody who's an ectomorph, right? Think of like any basketball player who's really tall, right? Tall, lanky. They don't put weight on easily. Their metabolism's super fast. Like they're kind of, some of them at when they were younger and growing, they were really awkward. Like that's an ectomorph, right? And you can kind of think about people and place them in that different category. You have mesomorph. That's like the more, like broader shoulders, more muscular, like heavier, not heavier set, but they're more dense of a person. They're not really tall, not really lanky. They gain weight like relatively easily, but it's not bad weight. That's a mesomorph. And then you have your endomorph. That's like you're more heavy set in the hips. You don't really have broad shoulders. You do put weight on easily, like those kinds of things. Like there's different aspects of them that can help you just like from a baseline standpoint of understanding like where basic and general people are at. And you can use those to help you a little bit, but more so you're going to have to look at the individuals that you're working with and go from there. The last thing I want to go over really quick is android obesity and gynoid obesity, okay? This is just another terminology thing that you need to understand. And if you look, you got the apple and you got the pear, okay? All this is trying to represent is where somebody who's obese holds most of their fat, and then it's depending on that, you can understand which one is more of a risk than not, right? So the android obesity is the big gut, right? So we all know people who have like kind of normal legs or like decent like legs that don't look super like fat, but then their gut and around the abdomen is just huge fat, right? That is android obesity, and the problem with that is that you have a ton of that fat just sitting right around all your essential organs, compared to the gynoid obesity where you look like more like a pear, so the person's upper body is like almost normal, but then their hips and their butt and their legs are just like totally, it doesn't even match their body. Right, that would be the gynoid obesity. But the good thing about that one, or the better thing, is that it's not all sitting around the essential organs in the abdomen. So when you're looking at the differences in types of obesity, you'd rather have the gynoid one than the android one, just because of that difference. Okay. All right. So this is what we're gonna do. We'll call this lecture 5, part 1. So that way you can take a little break and kind of focus on this stuff specifically. I'm going to make a whole other video for the next part, which is all the flexibility stuff. So this is like a whole other topic on its own. So we'll keep them separate on here. You'll see lectures 5 part 1, lecture 5 part 2, and I'll label it too so that you understand it. So if you got time now or whenever you want to do it, head over to lecture 5 part 2 where we're going to flexibility.